Alright, here we go. Right triangle trigonometry ratios. Okay, I'm going to skip these first bullet points because I'm not sure exactly where I was going with doing that, but it doesn't matter. Okay, let's talk about labels, because if we can't, if we don't know the labels, we're not going to be able to do the trig functions. Okay, we're going to use this angle right here as our reference. Now you guys know the name of this side. What is this side right here? Yeah, that's the hypotenuse. Okay, it still stays the hypotenuse. Okay, I'm just going to abbreviate it and write hype. Okay, now, using the A as our reference point, what do you guys suppose the name of this side is?
Opposite.
Yeah, opposite. I don't have to abbreviate this one. I'm pretty sure I know how to spell that one. Okay, and then what would this side be, the name? Like, adjacent. Yeah, that's not a word that you use every day. Adjacent, I think of as like right next to, but, oh dang it, I don't know how to spell. Adjacent. Okay. Sine is usually abbreviated. It's normally written with just this, S-I-N, sin. Cosine is usually written like this, cos. And tangent is usually written like this, tan. Okay, abbreviated. All right. These are the ratios of the sides of a right triangle. Okay, and they use the angles of a right triangle to do it. So here, this is what they look like. Now you can use this acronym. This acronym kind of helps. I think of soaking toes. You guys ever do that? You soak your toes?
Well, suck your toes.
Soak, no, soak. Not. You said suck your toes. I can't believe you just said that. He said suck your toes. Weird. Why is that on your mind, dude? That's kind of different. No, soak a toe. Okay, I don't know. I'm just saying stupid things to try to help you guys remember it.
Soak a toe.
Yeah, SOHCAHTOA. Soak a toe.
Well, my teacher made a story for it of the trigonometry.
All right. So here are our ratios. Sine A is opposite over hypotenuse. I like abbreviating hypotenuse. Honestly, I'm just not sure how to spell it. See, sine is opposite over hypotenuse. And so the first three letters, that's your sine. Okay? Here's your sine. Okay, cosine A is adjacent. We'll put adj over hypotenuse. Okay, see the C-A-H? Okay. And then tangent is opposite, see the O? Opposite over adjacent. So we're going to put op right here and adjacent right here. Okay, and then you can abbreviate this stuff. S is O over H, C is A over H, and T is O over A. Opposite over adjacent. I'm just giving you guys pretty much like vocabulary words right now. These are the trigonometric ratios. These are, yeah, trig ratios. Ratios is another word for fractions. All right, for the triangle shown below, find the sine A, cosine of A, and tangent of A. So this is our A right now, this angle. So we have a new reference point. Now for sine A, for this angle right here, what is the opposite side for the A? It is 3. So we put 3 right here. And then what's our hypotenuse? 5. Okay, the hypotenuse is always the same. It doesn't matter what you're referencing from. Okay, now for the cosine, we have adjacent over hypotenuse. So we have adjacent, which is 4, and then our hypotenuse, which is 5. Okay, and then finally we have tangent, which is opposite over adjacent. We're going to write, wait, which one's the opposite here? The 4, 3, or the 5?
3.
The 3, and then adjacent is 4. All right. Easy peasy. You guys are with me? Bam. Next one. Okay, so for this triangle shown, find sine A, cosine A, and tangent A. Okay, but we're missing this side right here. How are we going to find this missing side? The Pythagorean Theorem. Okay, let's abbreviate that. Let's just call it Pyth. Can I call it Pyth? You could call it whatever you want. Okay, well, how about Pythag? Yeah, Pythag. Okay, the Pythagorean Theorem. Okay, so to find that side, you can use the Pythagorean Theorem, or you can actually use Pythagorean triples. Ooh. Yeah, this is 24. Okay. If you use that stuff, you get 24. Okay, so now we can find all of our ratios. No problem, yeah? Okay, A is right here, so that's our reference point. What's the opposite side for the A? 24, because we're doing sine first. And then the hypotenuse? It's going to be 25. And then for cosine, it's adjacent. Adjacent to A is going to be 7, and then our hypotenuse is still 25. So we have 7 over 25. For tangent, tangent would be opposite of the A, which would be 24, over adjacent, which is 7. So we have 24 over 7. Okay, now if you're having trouble remembering this stuff, you either have that SOHCAHTOA in your head, or you wrote it down so you have a reference point. So while you're practicing this, you can start memorizing it. Yeah. Now check out this one right now. That was not bad at all, right? I mean, that was kind of like still vocabulary. Now down here it says if sine of angle A is 5 over 13, then what is cosine and tangent of A? Well, what did we have up here that made this one so easy that this one doesn't have? A triangle, a diagram, illustration, however you want to call it. So I'm going to draw myself a triangle right here. And it doesn't matter which angle you make A, it just can't be this angle right here. So let's make this angle right here A. Okay, so we know that sine of A is 5 over 13. So do we know any of the side measures?
Yeah, 13.
Yeah, okay,
No,
where's the 5?
5 is going to be opposite of
Opposite. So opposite of A is right there, so I'm going to put a 5 right there. And 13 is the hypotenuse. Is this a triple? I think it's 5, 12, 13. Yep, 5, 12, 13.
Yeah, we just did.
Okay, yeah, we did that earlier. Okay, so I just found the other side. Some of you guys might not remember triples, and if you don't remember the triples, that's fine. You can use Pythagorean Theorem. Okay, remembering triples kind of makes things a little more simple, though, so I recommend it. So now we have cosine of A equals, let's write that right here. What is cosine of A? Well, A is right here. We have adjacent, which is the 12, over hypotenuse, which is the 13. So we have 12 over 13. That's one of our answers. And then for tangent, tangent is opposite. So we go back to our A. The opposite is 5. So we'll put 5 over adjacent, and the adjacent, again, is 12. All right, let's look at this one. This one says, find the sine, cosine, tangent ratio for 30 degrees. Oh, how can we do that? I don't see a triangle right here.
Draw it in 30, 60.
Yeah. Now, drawing the triangles always helps with the problem-solving process. So, if you're not sure, draw a triangle and then see if you can do it. I'm going to throw 30 degrees right here. Okay, so there's my 30. Oh yeah, it's a 30, 60, 90, huh? So if this is a 30, 60, 90, do you guys know the measurements of all the other sides? I remember the hypotenuse has a 2. Is that one supposed to be radical 2 or just 2?
It's 2.
Just 2. Okay, there's a radical here, though. Where's the radical?
Underneath the 30.
Yeah, where the 30 is. And so, oops, I put 30 degrees there. Okay, that's supposed to be red 3. And then what's the last side? 1. Now this is your reference angle. Okay, so that's what you're referencing. It doesn't matter where the 30 degrees is. I put the 30 degrees there. You could have drawn your triangle like this and put the 30 degrees right here. That would change what your sides are. Now the hypotenuse would stay the same. Okay, but it changes the rad 3 and the 1. This time the rad 3 is right there and the 1's right there. And then your reference angle would be this. But you'll get the same answer for your trig functions because what matters is the angle, not where it's at. Alright, so let's write this out. So we have sine of 30 degrees. So 30 degrees right there. What's opposite of 30 degrees?
1.
It is the 1. So I go opposite, which is 1. See down here, its opposite is still 1. Oh yeah. Okay, it's opposite over hypotenuse. So what's my hypotenuse?
2.
Dose. And so the next one would be cosine of 30 degrees. Cosine is adjacent to 30 degrees, and so the adjacent is rad 3. So rad 3 on top over hypotenuse, which is 2, and our last one, which is tangent of 30 degrees, would be opposite, which is right there, the 1 over adjacent. So we have 1 over rad 3. Now, for you guys, I don't want you guys to leave your answer like this. You can't have the radical on the bottom. So what do you have to multiply the top and bottom by? Yeah, multiply by rad 3. You guys are good at this. So we got rad 3 on top. And what is rad 3 times rad 3?
Rad 9.
Yeah, rad 9. Thank you for not skipping steps as we learn. We have rad 3. And what is radical 9? 3. Ba-bam, ba-bam. And you can't... Wait. Can I simplify this? Can I cross out these 3's? No. Why not? Because this one has a radical on it. That's why not. Okay. Why don't you guys go ahead and try this one right here. It says, what is the sine and cosine of the ratio for 45? All right, so I drew a triangle. All right, if one angle is 45, that means it's a 45, 45, 90. Your reference triangle says that these are 1s, and that's a radical 2. Remember we did that? Oh yeah, that's our reference triangle for 45, 45, 90. What is sine of 45? Well, it'd be 1 over rad 2, right? Opposite over hypotenuse, and the hypotenuse is rad 2. And so that would simplify to rad 2 over 2, because you can't have a radical on the bottom. And for cosine of 45 degrees, we get the same thing. That's adjacent, and that's hypotenuse. And the question is that surprising? I guess I just wanted you guys to think about it. Is it surprising? Not if you know what a 45, 45, 90 is.